Hello, my dear students. Today, I'm going to discuss with you the basic concepts related to the topic clocks. The clocks that we are considering, it's an analog clock. The clock, it consists of a dial, a minute hand, and an hour hand, as you see. So let's get started. First, I shall cover the rotation dynamics pertaining to the minute hand of the clock. You all know that the minute hand of a clock, in order to cover 360 degrees, that is one full rotation, it takes 1 hour span of time, right? So let me put it the other way around. In 1 hour, the minute hand, it covers 360 degrees. You know that 1 hour is 60 minutes. So in 60 minutes, the minute hand, it will cover 360 degrees, which means in 1 minute, the minute hand, it will cover 6 degrees. Now, let us talk about the rotation dynamics pertaining to the hour hand of the clock. Consider the time duration that is from 12 noon to 12 midnight. So that corresponds to a 12-hour duration, right? So the hour hand, it will cover 360 degrees, one full rotation in 12 hours. Let me put it the other way around. In 12 hours, the hour hand, it will cover 360 degrees, which means in 1 hour, the hour hand will cover 30 degrees. But you know, 1 hour is 60 minutes. In 60 minutes, the hour hand will cover 30 degrees, which means in 1 minute, the hour hand will cover half a degrees. So the minute hand, in 1 minute, it will cover 6 degrees. The hour hand, in 1 minute, it will cover half a degrees. So in 1 minute span of time, the angular separation between the minute hand and hour hand, it will change by a factor of 5.5 degrees, because 6 degrees, the minute hand is moving in one direction. Half a degrees, the hour hand is moving in the same direction. So between them, the angular factor that it changes, it corresponds to 5.5 degrees. So make a note of this input as well. Now, let's discuss how to find the angle between the hands of a clock when the time it is given. Please look at the time here. The clock shows 3 o'clock, right? The time is 3 o'clock. So the angle between the hands of the clock, when the time it is 3 o'clock, we can very well make out that it is 90 degrees. All right. Let's look at the time here. It's 6 o'clock. The angle between the hands of the clock when it's 6 o'clock, you know, it is 180 degrees. In the same way, when I am considering 9 o'clock, we can say that the angle between the hands of the clock, if I am measuring it in the clockwise direction as shown, that corresponds to 270 degrees. That is correct. In the same way, I can also consider that it is equal to 90 degrees when I am measuring in the counterclockwise direction as indicated. Okay, so in general, if the time it is given to find the angle between the hands of a clock, you can use this formula directly. Theta is equal to 11 by 2 m minus 30 h. This is a very handy formula. 11 by 2 m minus 30 h, where m, it corresponds to the minutes and h, it corresponds to the hour. All right. Now, kindly note, when you are doing this calculation, if you get a theta value, if it is greater than 180 degrees, and that theta value what you calculated, it is not listed in the options. Okay, then you perform 360 degrees minus theta what you calculated, and then check whether the angle it is presented in the options. When you are attempting a question while you are attempting a placement test or so, By applying this formula, when you calculate the theta value, and if you find that theta it is greater than 180 degrees and it is not listed in the options, please check 360 minus theta and then see whether it is presented in the options. All right. So you will be finding this concept very useful for solving a few questions. But this formula, theta is equal to 11 by 2 m minus 30h. It's a very important formula. Please make a note of that. Now, as an example, let's consider the time that is presented here. This clock, it shows the time that is 12:26. As you can see, the time that is shown here is 12:26. So to find the angle between the hands of the clock, you can use 11 by 2 m minus 30h. M, it corresponds to the minutes. So you can see M, it's 26 minutes. So you put M is equal to 26. H, it's 12:26. So H, you straight away put the value for H here as 12. And you do the calculation, you will get the theta value here as 217 degrees. Now that 217 is nothing but this measure. Okay, 217 degrees. But since 217, is greater than 180 degrees, then you immediately perform 360 minus theta. So 360 minus 217 when you do, you will get 143 degrees, right? And we can consider that the angle between the hour hand and minute hand, that is equal to 143 degrees also. Okay, so you just check if it's asked for a placement test or so, you just check which option is presented and then select that correct option accordingly. Okay, fine. Now let's go to the concept frequency of occurrence. This is very important. You just consider the time duration that is from 12 noon to 12 midnight. 12 to 12 I'm considering. Okay, so over a span of 12 hours, the minute hand and hour hand of a clock, it will be coinciding with each other 11 times in every 12-hour span of time. Okay, so these are the instances, as you can see, where the hands of the clock, they coincide with each other when we are dealing with a 12-hour span of time from 12 to 12. For better understanding, I am presenting those instances where the hands of the clock, they coincide with each other. You can see altogether I have presented 11 instances. Okay, where the hands, they are coinciding with each other. For better understanding, I am even presenting the time wherein they are overlapping with each other. So from 12 to 12 in 12 hours, they coincide with each other 11 times. So make a note of this detail. In the same way, the hour hand and minute hand of a clock, they are 180 degrees separated 11 times in every 12 hours. You are considering from 12 noon to 12 midnight time duration. Altogether in 11 instances, as you can see, the hour hand and minute hand, they are 180 degree separated from each other. 180 degree separation means the needles, they will be pointing in opposite directions. Okay, so please be aware of these instances where these hands of the clock, they face opposite directions. All right, so you should study this particular table, whatever the values that are presented in this table, by heart for solving questions that deals with calculating the frequency of occurrences of certain scenarios over a span of 12 hours. The coincidence, it happens 11 times as indicated. 180 degree separation, it also happens 11 times as indicated. Any other theta, it will happen 22 times. And over a span of 24 hours, you can consider that all these values will be getting doubled. So coincidence, it will happen 22 times. 180-degree separation, it will happen 22 times. Any other theta, it will happen 44 times when we are dealing with one day, that is 24-hour span of time. So please study these values and keep these values handy while you are solving problems. Now, let's consider clocks losing time or gaining time. As far as a clock is concerned, 65 and 5 by 11 is a very important value. The time gap it takes for two successive coincidences between the hands of the clock, it is 65 and 5 by 11 minutes. I shall explain this in detail. At 12 o'clock, the hands of the clock, the hour hand and minute hand, they coincide with each other, right? Try to visualize what is 60 minutes past 12 o'clock. 60 minutes past 12 o'clock. You know that 60 minutes past 12 o'clock is nothing but 1 o'clock. So can you tell me what is 65 minutes past 12 o'clock? 65 minutes past 12 o'clock is 1-5. So you can see that at 1-5, close to 1-5, the hands of the clock, they are coinciding with each other, right? So the exact time duration, I will say, it is 65 and 5 by 11 minutes. That's the time gap between two successive coincidences between the hands of the clock. This value, you should keep it always ready. Okay. Now, consider a scenario wherein a clock, it's taking more than 65 and 5 by 11 minutes to show the coincidence between the hands of the clock. Then you can see that the clock is actually getting decelerated. The clock is losing time. That's what it means. Okay, in the same way, if the time gap between two successive coincidences, if it is less than 65 and 5 by 11 minutes, then understand that the clock is getting accelerated. The clock is technically gaining time in this process. Okay, so make a note of this input. In the same way, let us now talk about the reflections part. You know that the time that this clock it shows, it's 3 o'clock, right? So imagine the situation. You are holding a mirror straight in front of this clock, and then you are watching the reflection, the time in the reflection, what you see. You can see that if the time is 3 o'clock, if that's the actual time, if it is 3 o'clock, you can see that in the reflection, you will see 9 o'clock, right? 3 o'clock, you hold a mirror in front of this clock, you look at the reflection, it looks like 9 o'clock. In the same way, let us consider the time that you see here is 6 o'clock. Let us consider that that's the actual time, 6 o'clock. So if you hold a mirror straight in front of this clock, which is showing 6 o'clock, and you look at the reflection that you see in the mirror, you can see the reflection also will show 6 o'clock. So the actual time is 6, the reflection also is 6. In the same way, you can see that the time that this clock shows, it is 9, right? Imagine that you are holding a mirror in front of this clock and then you are looking at the reflection. For 9 o'clock, if that's the actual time, you can see that the reflection that is going to show 3 o'clock. Got it? So here you can see an interesting observation. If the actual time, say it is 2, in the reflection you will see 10. You can try this out. Okay. If the actual time it is 4, in the reflection you will see 8. If the actual time is 6, the reflection will be 6. If the actual time is 8, the reflection will be 4. If the actual time is 10, the reflection will be 2. So any time that you are considering between 1 o'clock to 11 o'clock, both times included, then actual time plus reflected time, you can consider that it is equal to 1160. 1160 is nothing but 12. You can see 10 plus 12, 10 plus 2, that is equal to 12. In the same way, 8 plus 4 is 12. 6 plus 6 is 12. 4 plus 8, that is 12. 2 plus 10, that is 12. Are you getting me? So, all these cases, the actual time and the reflection, if you add, it is equal to 12. But I would rather present it as 1160. There is a reason for that, because let me consider the scenario where the actual time, say, it is equal to some 348. Let me say the actual time, okay, let it be equal to some 348. Okay, you know the 348, it lies between 1 o'clock to 11 o'clock. Correct? No, it lies in between 1 to 11. So, actual time plus reflection, that is considered as 1160. The actual time, it is 348 plus reflection. We want to find out what it shows in the reflection. So actual plus reflection is 1160. I can see that the reflection that you see, it will be 1160 minus 348, and that comes to 812. I hope it is clear to you. So when the actual time the clock shows it is 348, what you see in the reflection when you hold a mirror and then look at that reflection, what you see in the reflections, it will be 812. Okay, so you will be using this result for answering a few questions that deals with the actual time and the reflection. So any time between 1 to 11 inclusive of both, actual plus reflection is 1160. In the same way, any time between 11:1 to 12:59, please make a note of that, 11:1 to 12:59, inclusive of both, you can see that actual plus reflection, it will be equal to 24. Okay, for example, imagine the case where the time that the clock shows, the actual time that the clock shows, it is 12 o'clock. So in the reflection also, you will see 12 o'clock. So if actual, it is equal to 12, reflection also, it is equal to 12. You can see that actual plus reflection that you see, it is equal to 12 plus 12, 24. That I will present it as 2360. Why I am presenting it as 2360? Why did I present earlier that value as 1160? That is to consider the minute aspect when some crazy time it is given. Okay, so that is the only logic here. So coming to the point, as far as this time instance from 11:1 to 12:59 inclusive of both, please note A plus R, it is 2360. All right. So as you can see, if the actual time is 12:23, let us consider the reflection, what you see, it is R, that is equal to 2360. From this, I can say the reflection will be 2360 minus 1223, which will come as 1137. So that's what the reflection that I have presented here. All right. So once you are clear with all these concepts, there are two more things that you should be aware of. Direction sense based questions, that's from this topic, that is clocks, and also how much time the clock it loses or gain in a day as such. So those concepts we will discuss in the form of problems while we meet in the class. Okay, so these things that you should know before you are attempting the questions from our workbook. So that is what we have done in this introductory video session. All right. So please learn all these concepts well before you join for the actual classroom discussions. Thank you for watching. Wish you all the best.